Hello, and welcome to this video for solving exercise 9.2 in chapter 1, but using a graphical method called the tip-to-tail solution, or sometimes referred to as a head-to-tail solution. There is a previous video where I solved this sort of with mathematics using the I-hat, J-hat. You can see what we got as the final answer there. I urge you to take a look at that video to sort of understand how we did it mathematically. Now, in order to draw the solution, we're going to need to make a scale drawing. Now, the question itself gives you 1 centimeter for 2 newtons. This is if you're going to do it on paper, especially like graph paper. Now, I'm using a digital screen here, so I'm going to do it slightly different. Now, in order for you to do it, you can actually choose any scale you like. I'm not too picky. The only thing you want to do is make sure you do it so your diagram is big and not like a super tiny diagram, because that'll mess up your measurements. So what I'm going to do for this one, since I'm using my digital iPad and it's already in a nice grid format, I am going to use 1 box is equal to 0.5 newtons. Now, to start, I need to pick some random point to be our starting location. It doesn't matter where you put it, although you do want to try and choose it so when you're going to add these together, you have enough space. So I've just chosen it here. There's nothing special about that location, except for the fact that I've already done some trial and error and know that this is going to give me room to draw everything. You can actually now draw these vectors in any order, as long as you've only drawn each one once. So I thought I would start with Fn. Nothing special about it other than it's easy to draw. And Fn is 2 newtons upwards. So 2 newtons on my scale is going to be 4 boxes. So I am now going to draw an upward arrow that goes up 4 boxes. And I want you to notice, and I'm going to erase these in a second, but you can see that the tip of Fn is where the arrowhead is, and the tail was down at our starting point. And what we're going to do now is add the next vector on, starting the drawing of that vector from the tip of Fn. So I'm going to choose to do Fap, and because I'm going to start at the tip of Fn, Fap is just plus 2 newtons upwards, so I'm going to draw another arrow that goes up 4 boxes and label that Fap. So we've taken care of 2 of the vectors now. I'm going to add the third one on T, and I'm going to put its tail at the tip of Fap. And T is 6 newtons to the right, or 12 boxes to the right by my scale. So now I'm going to draw an arrow that starts at the tip of Fap and goes 12 boxes to the right. So now we'll do the next vector. Now, I want to keep the diagram clear. And as I said, you can draw these in any order. So what I'd prefer to do now is do Fg. The reason I'm not going to start with just the F of 4 newtons to the left is because then I'd have to draw right on top of that arrow I drew for T. And just for clarity, I don't want to do that. So for Fg is 2 newtons down, or 4 squares down. So I start at the tip of T, and then I draw F going 4 boxes down. Now the only remaining vector left is the 4 newtons to the left, which turns out to be 8 boxes to the left. So at the tip of Fg, I am now going to draw my arrow 8 boxes to the left, and that represents that little f force. And now we have all our forces represented on our diagram. And since all the forces are taken care of, notice I can now set the tip of that last vector added. That is going to be my endpoint. Now, the neat part of this is we can now calculate the net force. And only thing we have to do to calculate the net force, which is the sum of all forces, is we draw an arrow from the start point to the end point. Now, be careful because we've been doing sort of tip to tail on top of each other. This kind of reverses it. We are actually drawing a different vector from the start to the end. So a lot of people end up just trying to do the end to the start to complete the tip to tail. That's incorrect. Draw a vector for the net force that points from the starting point to the ending point. That is the net force. the sum of all the forces added together. Now, looking at that force vector that goes from the start point to the end point, that's the resultant force, or the sum of all forces, notice that it has a part that goes 4 boxes to the right, and then a part that goes 4 boxes up. In other words, 4 boxes to the right equals 2 newtons to the right by my scale, and 4 boxes up is 2 newtons up by my scale. And so as a result, this single vector from the start point to the end point, which is the net force, can be represented as 2I plus 2j hat, and then the unit, of course, is the newton. And we get that just by looking at the scale of the drawing and the number of squares along the x and along the y. This solution matches the one we found using I hats and j hats. You can see the other video for how we did it mathematically, but you got the same solution. So you can solve these force vector problems by analytically, which is mathematically with I hat and j hat, or graphically. Now, I will say that the graphical thing isn't always extremely useful because, of course, there's uncertainty when you're drawing, and as a result, it's not going to be as exact as doing it mathematically, and also it does take a little bit of time. If you are interested in exploring more of this graphical nature of doing these, I suggest repeating this problem, but add all the vectors in a different order, because as I said, the order that you add them and draw them doesn't matter. You'll get the same exact result. So you and other student or somebody else trying this may have different looking diagrams because you added them in different orders, but whatever vector you end up drawing from your start to your end will be exactly the same as any other person in the class would do it. There'll be 4 boxes to the right, 4 boxes up. So that is the solution graphically to example 9.2. As always, if you have any questions, please get into contact with me. I'm happy to go over any of the concepts or answers with you. Other than that, I'd like to thank you for watching. I hope you have a great rest of the day, and we'll see you soon.